Welcome everyone to this session on digital twin, and today we have a special guest, Seshadri Guha, who is the CEO and co-founder of Tada Cognitive, and I think he's probably one of the few people who have been talking about digital twins for the longest time and doing research into how to extend this concept further. So today we want to learn from him in terms of, first start with maybe what is the evolution of digital twin, Guha, that you are very familiar with. So what have you seen, how this market has evolved, and what are the challenges you saw?
Yeah, thanks, Paul, appreciate the introduction. So the idea of digital twin has been around for a long time, but I think it became more popular with this idea in computer-aided engineering early on. That is what I call the first kind of the single-cell amoeba model of a digital twin. So if you take an organization may have a machine, it may have a product, it may have a factory, it may have hundreds of things that makes up an organization. So the digital twin, it's interesting to know I have a digital twin of one place, right, in the organization, but I may have 50 products, right? But that's not the real problem. Those 50 products are connected to 500 parts, and they are connected to 20 factories which make them, right? So all of a sudden, the digital twin itself of one is useful, but it's really in a complex organization, it's the associations, right, between these digital twins that is a better reflection of this. So then the problem is, how do you deal with literally thousands of digital twins and build a digital twin of an organization, right? That's really, the problem that we were trying to solve, because to solve complex businesses and solve for them, we had to create a view that allowed them to not only see all the connected pieces, but maintain a real-time view of it. And so we took some inspiration from nature and said, is there a similar way to build a digital twin of an organization, right? What that meant is we had to come up with a DNA that could repeatedly represent the underlying structure, which would be corresponding, which we call a synaptic model, neurosynaptic model. Then we said we have to be able to represent the genome of an organization, right? What makes up the structure of the organization that can be encapsulated. Now we could use this to organize and build take all the information, right? The organic material inside a digital material inside a business, and build a virtual twin of the entire organization, which is basically creates. So now this approach, which was basically said, can we build the genome and use it to invert it to actually build a digital twin of an organization? That experiment was pretty successful because it allowed us to deal with massive complexity, right? Build it for very complex organizations, and actually not only build it, but actually maintain the digital twin, right? Along with the full rich associative model, right? So we could use it to bring together data and digital information and recreate in very, very short periods of time and create millions of digital twins that were all within a shared fabric. So we did 3 different experiments. First one was a traditional, right, digital twin. The second one was a kind of, think of it, a multi-cell organism, which could not only have multiple digital twins, but within one fabric, right, that we could create for a very complex organization at extraordinary speed. But we realized that even that was only representing data, right? We had to make it really useful. We had to now connect mind and machine. And that required that we actually integrate the language and the way people think and the way they connect information into. So that led us to the third level. So what this creates is a unique situation where we have now been able to solve at that level 2, the organic digital twin. We've been able to encode the data that we get from organizations with the underlying the DNA of the business, and all of a sudden be able to create a virtual duplicate. But because that DNA is now semantic, we are now able to make it easy for people in that organization to not only visualize, to navigate, but also collaborate. Right? So it has unfolded. So this goes beyond this idea of how do we collect and manage data. It's about how do we collect and manage, organize information across very complex ecosystem with extreme speed and purpose. Beyond that, to make it, how do you organize information in a way that is natural and comprehensible to the average person? So that's been our experiments with the digital twin. And
so
yes.
So Guha, I think you brought in quite a few concepts here, so I want to just try to bring them together. So you said the evolution came from the original digital twin concept to obviously the first generation of digital twin was simply a picture, which as we added more element and more simulation, we created the digital twin of the product, which is where the industry has been for the last few years. And then you took that concept and applied it to creating the digital twin of the organization so that you can basically bring all the systems and their connections and their nodes and the links together into a coherent form. And then you said that the next step you did is you thought that, hey, you got to create a semantic or cognitive layer on top of it so you can actually make it more useful to reduce the complexity. And on top of that, you needed the help of, if you might, a data fabric where the data from various systems is coming into this fold, so this becomes alive. Is that a good representation so far of, and is there any key point that I'm missing that you want to add?
No. I think you're exactly on target. I think traditionally we tend to worry about what I would call the data and the data fabric, right? Our traditional models of thinking are based on the fact that we believe data represents, right, the value. Actually, that data fabric is interesting, but only when the data fabric is created into an associative model, right? Where every element, right, every component in that, right, describes every other component, right? That creates a very enriched model, right? So it's not about the data, because data can be represented by the data about something. It could be about parametric representation of data. But beyond the data, the question is, how do you now bring together, synthesize, right, the fabric of all the twins? But each twin now has to be a descriptor of every other twin. Now the value of information you get goes far beyond the data. So I think the question here is not about solving a data problem, because data is a rear view mirror problem. You have data about things that happened in the past, right? It's about connecting the elements to create that integrated view. But even that is not the problem. The real problem is when you have thousands of, right, 5 or 10,000 people working together every day. How do you allow them to know what they have to look at and focus on today? And how do you allow people to collaborate with each other on the same fabric? So the Tada experiment that goes beyond data, right, has been able to demonstrate not only the technology, but the scalability across complex and speed and scalability, but the ability to drive not beyond visibility, orchestration, movement, but collaboration across very complex ecosystems, right? All in, right, by encoding this DNA versus writing code every day.
Okay. So is it fair to say you're saying, okay, so you've applied this problem, this technology into supply chain problems, because that's a very complex set of issues where you're dealing with multiple parts, multiple things, and there are various personas involved, with each of them requiring their own type of an information, because an executive doesn't need the same information that the material planner needs or someone else. So you will be able to give them this level of information. And I know you probably can't name your customers, but it will be interesting to hear for people that, hey, what kind of customers have really deployed this technology today? And also, do you really have to, when you say digital twin of an organization, it scares some people to believing, oh my God, this is going to be like, I have to convince everybody in my organization to buy off on it. And do they, or is there another way of thinking about it?
Yeah, so let me answer both of those questions. So today we probably have upwards of $20 billion of real-time assets that are running on the Tada platform across 50 to 60 companies, right? These are some of the largest companies in the world, right? In it between 5 and 20 and $20 billion companies, right? And we have within that, we have a real-time view and a digital view of every part that's moving across every product, right? Every factory and everything being produced, connecting all of it together into one weave where thousands of people are actually working together, right? But this was the effort that went behind this was not years, it was months, right? Amazingly enough. But I'll go to your second question. Your second question is, hey, this sounds very complicated, right? So do I have to basically do the whole thing? So it kind of turns out to be, it's like a funny, simple answer, right? If I wanted to get your DNA, right, do I need your whole body or do I need one blood sample from you, right? So if you invert the problem, when we go into an organization, our experiments are very small. We will take one factory, right, or one function like procurement or purchasing, and we build the digital twin of that organization. But guess what is inside that particular function? The DNA of that whole organization is in there, right? So once we start small, we can build something, use that to basically help them extend, right, the functionality from, you may start with a factory, you can take it to their suppliers and the supply chain, you can take it from there to their distributors and dealers, right? It's so natural and organic that you can now build it and expand it, right? And as you expand it, the complexity of your problem keeps going down exponentially, but the value you get goes up exponentially.
So Guha, this is interesting, but organizations have bought hundreds of systems. So much of investment has already been made. Are you trying to suggest that they have to replace some of these things, something that they already trust?
No, not at all by any means, right? That would be an impractical solution, right? I think the question is, how do we help organizations and business leaders, right, digitize and disrupt their business, but not digitize and disrupt their existing systems and processes, right? That's the trick here. We have to be disruptive in a good way, not disruptive in a bad way, right? And that's exactly what we are able to accomplish. So I think the way that Tada operates is it creates this common structure and is able to now integrate data from multitude of systems seamlessly, right, to create one shared fabric. So we don't ask any of our customers to replace their existing ERP systems, warehouse systems, management, sales, right, their CRM systems, and right, the dozens of TMS systems, but we are able to rapidly integrate all of this within one fabric. But as soon as we are done, every piece of data from all of this is now organized, and now the data now becomes aware of what it does and where it fits in the business. And when people are in the organization are also part of this. So think of Tada as, so we basically massively reduce the complexity of integrating data across systems, right? And not only that, but doing it in real time. And this creates that level of visibility agility and flexibility, which is so critical for organizations in times like this, right? Where the market is changing so rapidly, and your business risks are coming at you from so many points of view, right? And you need to be resilient, right? You need when things are coming at you and you see new disruptions in the market, shocks in the market, right? Either on the supply side or the demand side, or right in other areas. How does the whole organization have visibility to it in a secure way, right? That means you don't want everybody seeing everything. Security is just an integral part of what we do, right? Who can see what? So they can now see what they need to see, and they can respond to it together as a team, communicate with each other and respond. So this takes organizations, orders of magnitude, right? From what we call, it's like giving the average business what we call an Iron Man suit, right? We put the Tada suit on, all of a sudden they have the superpowers that, highly digital companies can have without having to change their internal structure, right? So we are able to integrate their way of doing business, their business model, their process partners, integrate all of them to make that happen, right? So we are not, we don't disrupt their business or their existing systems. But I do admit that many of our customers, after they implement Tada, they use the structure of Tada to basically take away some of the legacy systems, because the cost of eliminating legacy systems goes down dramatically once you have a Tada, right, landscaped view. Right? Now they can selectively go and pull out systems and replace them, because they have now encoded the entire business with a common language. Making information talk, data and information talk in the language of people. Right? If there's anything at all we should say we do, all this is technical and technology. That is the single biggest thing that can unleash the power, right, of what we can do together.
Okay. Well, thank you very much. Really appreciate it.